Hi, I'm Peter Rumsey, and I'm going to introduce the concept of building decarbonization. This is part of the Stanford Building Decarbonization Learning Accelerator that was founded in 2021 to promote the teaching of building decarbonization concepts in higher education. So, what is building decarbonization? Building decarbonization is the idea that we can now build buildings that are fully decarbonized, that do not emit carbon. And carbon emissions are a big part of what's causing global warming, and there's a new sense of urgency around decarbonizing buildings. In buildings, there's two sources or types of carbon that are emitted. One is from the construction of the building itself, and we call that embodied carbon. And the other is operational carbon. That's from the emissions from using energy in the building. And it could be either by burning natural gas in the building for heating or using electricity that is created from fossil fuels. So we're going to talk about both of those today. Let me start by talking about embodied carbon. Embodied carbon can be handled or thought of by looking at very carefully the building materials. We oftentimes find that the structural system is the single largest emitter of embodied carbon or causes of embodied carbon. And so when we're looking at buildings, we can investigate concrete, steel, and wood or other structural systems and find and calculate their embodied carbon. You can see in this example for a 175,000 square foot office that the embodied carbon can start with concrete around 30 million pounds and go down to the low 20s for steel, and then below 20 for wood. And in fact, wood itself sequesters carbon, and some people do make the argument that wood could even be a negative carbon impact. If we're working on a building that has to be concrete or steel, there's steel companies and cement companies that are now making products that have very low embodied carbon. They're consciously trying to figure out how can we make cement that emits less carbons. And less carbon. Some companies are actually offsetting or looking at their operation and saying we're going to run our operation with either renewable energy, or if we have to use fossil fuels for the process, as is the case in cement, we are going to make sure that we offset the carbon emitted as part of the process of making cement. So generally what we're doing for decarbonizing the embodied carbon in buildings is we're selecting low carbon building materials. At the end of the day, it's hard, if not impossible, to fully eliminate those. And so what most projects are doing are taking the remaining embodied carbon of the building construction, and they're buying offsets, carbon offsets, certified offsets, ones that result in the production or the installation of more renewable energy, the improvement of energy efficiency in buildings, and a variety of other things. So offsets are a way to do this. It's not as good as lowering the carbon itself in the building, but it is considered, and when it's a quality offset, a valid way to handle or offset or decarbonize the embodied carbon of a building. So I'm going to spend the rest of the time talking about operational carbon, because operational carbon is the bigger of the two, and it is something that we now have a clear path to handle. So what is the path to decarbonizing buildings? So if we look at a typical building, the first step is making that building more efficient. Now that more efficient building will still be served by methane, or also known as natural gas, as well as electricity. Then we take that efficient building and we make it an all-electric building. So we substitute natural gas heating with electric forms of heating, generally heat pumps, which I'm going to talk about. And once we have an all-electric building, we can serve that all-electric building with renewably produced electricity. So when I say renewably produced electricity, I mean solar or wind power. And the solar can be put on the building itself, or we can purchase solar or wind power off the grid. So it's interesting on the building energy efficiency first step in this path. Buildings are generally getting more and more efficient. This is a graph showing that building stock has been increasing and is envisioned to increase. This is for the U.S. But the energy efficiency in what we measure kilobtus per square foot per year has been improving over time. And this graph on the left is up until 2021 is actually measured data, or 2020, and then the rest is projected. There's been many years and lots of information is available on building energy efficiency. But I'm going to focus a little bit more on some of the other elements today. The first thing to understand is that electricity is becoming, carbon-free electricity is becoming more and more available. 170 cities in 8 states have already committed to providing 100% carbon-free electricity by 2050 or sooner. And several states are in discussion of being able to create that or offer that. One state, just as an example, that has not made a commitment like that is North Carolina. But in North Carolina, you can, through the electric utility, Duke Energy, purchase renewable electricity. And so most states have an option, most utilities have an option where you can purchase renewable electricity. Some of the states have a program called community choice aggregation, which makes that easier, but we're seeing this as a rapidly growing thing, so that your money that you pay in your bill, you pay part of it for the wires and the distribution of electricity, but the part that pays for generation goes to solar or wind farms. So how do we electrify buildings, and what does that mean? Well, it's actually fairly straightforward. There's 3 places where we're using fossil fuels in buildings that we need to electrify. The first is space heating, and that's the biggest. The second largest is domestic hot water heating, and the third is gas cooking. So with space heating and domestic hot water, we can replace those boilers with heat pumps. So there's space heating heat pumps, there's domestic hot water heat pumps, and I'm going to give some examples of that. For gas cooking, there's now electric induction cooking. There's also been historically electric resistance cooking, and the electric resistance cooking is where the surface gets hot and you see a red element glowing when it's heating. But induction cooking is the newer version of electric cooking, and that's where it uses a magnetic field, and the surface doesn't get hot, the pot gets hot, and it cooks very quickly and precisely, and it's the most efficient way to cook. It's around 80% efficient, where gas cooking is only 30 to 40% efficient. So jumping into this idea of heat pumps, with a boiler, we burn gas. Some of it the heat gets lost in the exhaust, and then the rest of it provides heat. So for every units of heat that goes into a building, we have to put in on average, around 118 units of energy, fuel, in the form of natural gas. With a heat pump, we use a refrigeration cycle, and which is the same way your air conditioner works or your refrigerator. But a heat pump is able to pull heat from the air, the surroundings, and with the refrigeration cycle, turn that what might oftentimes be cold outside air or colder heat, turn it into a higher temperature heat and provide that into the building as heat. And because it's just moving heat, for every 100 units of heat that we need to provide to the building, we only need about, again, on average, a third of that, 33 units of electricity in. So heat pumps are significantly more efficient. When we look at the resource to room efficiency of a heat pump, when we're using natural gas and burning that in a building, again, it's this 125 units in for 100 units of heat out. But if we're using natural gas in a power plant and then put that through that electricity produced in the power plant into a heat pump, we only need 74 units of energy in. So natural gas is actually better used in a power plant connected to a heat pump. But really the best by far is when we use renewable electricity, renewably generated electricity in the form of solar or wind, and we deliver that to a building and use a heat pump. And in that case, we only need 35 units in. So you can see we're cutting the energy input to produce heating down by over 60% when we're using heat pump connected to renewable generated electricity. When we look at the CO2 implication of these three options, we can see that the by far the best is renewable electricity, where we can get it down to zero. Natural gas-based electricity is a significant improvement, but still does have the carbon emissions, which we are trying to get rid of. So there are different types of heat pumps out there. On the left is a picture of some residential heat pumps. They've been around for many years, and you can see them in homes that have a heat pump that in the winter time it can provide heating, and in the summertime it can provide air conditioning. And that's one of the wonderful things about heat pumps, is that they can be used in a reversible way so that they can provide on one day heating and on another day cooling. The commercial building version of that is a variable refrigerant flow system, also known as VRF, and it's becoming widely used around the U.S. And then there's larger commercial, industrial, what we call air source or water source heat pumps that are just dedicated to producing hot water for a variety of different things, including domestic hot water in a large apartment building. So electrification is fairly straightforward. The technology is there. Electrifying and decarbonizing buildings operation is now a fairly straightforward thing. So what policies are now being implemented to encourage electrification? There is a strong motivation to move in this direction. I live in California. In this year, 2021, we had 2.5 million acres were burned, in large part because we have a extended drought and our forests are very dry. But we're seeing now floods in a wide variety of places. And I can also remind you that there's been lots of different floods around the U.S. in communities, including New Orleans and Houston. Insurance companies are now very concerned that weather-related insurance claims are skyrocketing, and there is a lot of discussion of how our insurance company is going to handle this, and it really does threaten the existence of their business model altogether. So this is something that is not just a belief or not, but it's actually measurable, and companies are starting to respond. Globally, 40% of CO2 emissions are connected to the building sector. And so part of that, building operations, and the other part is building materials and construction. So really, buildings are the most important part of reducing carbon and handling the climate crisis. I would also say that the burning of fossil fuels in buildings does have a negative impact on air quality. This is a graph of the emissions from buildings as compared to cars in California. And this shows that buildings, and that is the combustion of natural gas in buildings, has a larger impact than driving cars. When we burn natural gas, it not only emits CO2, which is bad for climate change, but we're also emitting NOx, nitrogen oxides, ozone, and this PM 2.5, which is particulates that are very unhealthy to breathe. So burning of natural gas has a direct negative impact on our health today. Another interesting thing is that natural gas, we're now learning that when we drill for natural gas and then transport it to cities or buildings, that there is a certain amount of leakage that occurs, and it's in the neighborhood of 2 to 3%. The unfortunate thing is that natural gas, when it is emitted uncombusted into the atmosphere, is 84 times more potent than CO2 as far as a greenhouse gas. So when this 2 to 3% leakage occurs, it almost doubles the greenhouse gas impacts of natural gas. So another thing that's coming to play here is the fact that renewables, solar and wind, have become very affordable. In the US last year, over 80% of all new electricity is from solar and wind. And you can see this red line on the graph on the right is the share of or percentage of new generating capacity that's added to the grid each year from renewables, and that's only grown over the last 20 years. So now it is the single largest source of new electricity. It's beating out natural gas power plants, it's beating out coal power plants, and so we're seeing renewables, the use of renewables, grow very rapidly. Many states now have what's called a renewable energy standard for their utilities. This is a map of different states that do, and what it is a requirement that electric utilities meet a growing share of their electricity demand with renewables. So not only is there a growth in the use of renewables because they're becoming more affordable, but there's also mandates in states to deliver more renewably generated electricity. In 2020, the electric utility in Northern California called PG&E delivered 88% of its electricity from carbon-free sources. Also, large companies are making a move to use renewably generated electricity and make commitments. There is a program that the EPA sponsors where you can voluntarily sign up to get a growing percent of your electricity use and energy from renewable sources. This includes tech companies, which have lots of money, but it also includes a lot of big name companies that we're familiar with. So Starbucks and General Motors, Kimberly-Clark and Wells Fargo and Bank of America are all, and Procter & Gamble, Walmart are all participating in this and generating a larger and larger share of their energy consumption from renewable sources. This photo on the left is a data center that Apple built in North Carolina, and they said, well, we'll just build a solar farm next to the data center to power that and be able to have renewably generated electricity. So there's lots of states now that have policies towards electrification of buildings, and several cities are now putting in place sets of policies that will require reductions of greenhouse gases from buildings. So the market for heat pumps is growing, and that same with electric buildings. You'll see that these pie charts are showing the source of heating for residential buildings. And in the South, electric heating, much of it is heat pumps, is already coming from electric sources. And in the West, Midwest, and Northeast, it's much smaller percent, but that's going to be growing over time. And natural gas for heating is going to be shrinking. When I talk to folks who sell natural gas equipment, they're all now moving into the market for heat pumps and starting to sell heat pump systems. The heat pump system market, for one example here, is the VRF market is expected to double in the first 5 years of this decade. And so people are taking note. So I'd like to end with just a couple thoughts about building decarbonization. I think the first thing to remember is what are building occupants looking for? They don't really care if the heating is provided by natural gas or by a heat pump, but building occupants, they want comfortable environments that enable productive work and a sense of well-being, or at your home, ability to relax. So we really need to look at the outcome, and that is comfort in buildings, and we can provide that comfort with electrified buildings that are powered by renewable energy. I'd also like to bring up the fact that Black communities do bear a disproportionate burden of the continued use of fossil fuels. That's borne out in a variety of and is caused by a legacy of harmful building policies and practices, and also where we put fossil fuel refining facilities and such. And I'd also like to remind those of you who are listening to this video, if you're involved with building design or construction, or plan to be involved with building design or construction, that your ability to have an impact on greenhouse gases is far, far larger than just an individual. This comparison here is showing the carbon emissions of an average American over their lifetime, but as compared to a building designer over their career. And it's usually in the neighborhood of 1,000 times more impact as a building designer. So if you want to make a difference, if you want to address climate change through building decarbonization, you have a very, very strong role as a building designer or a builder. So I'm going to end there. This video, as I mentioned earlier, is part of the Stanford Building Decarbonization Learning Accelerator, and we've got a website at bdla.stanford.edu, and we urge you to visit. Thank you very much.